For sets of numbers, we have 6 different sets. The first one, R, which stands for real. All real numbers. Every number you've seen in every math class up until now is a real number. The only exception later on this year will cover imaginary numbers. Q stands for rational. Rational is basically any fraction, any number you can write as a fraction as long as the denominator and numerator are integers, and those would be positive or negative whole numbers. Integers, we'll use the letter Z. Integers, again, are positive or negative whole numbers. Anything that's on the number line except for decimals and fractions. Whole numbers, we'll start at 0 and count up. So 0, 1, 2, 3, 4, 5, and 6, and so on. Natural is almost the same thing, but it starts as 1 and counts up. 1, 2, 3, 4, 5, 6, and so on. And last one, I, for irrational. Irrational is a number, is a decimal that does not repeat or terminate. If it repeats or terminates, it's rational. You can write it as a fraction, but if it does not repeat or does not terminate or end, it's irrational. And it's also a square root that cannot be simplified. Title for the first section of the problem is name the sets of numbers to which each belong. First number we'll look at is the fraction 12 over 2. And we'll take this number and go through these 6 sets of numbers and see if it belongs to that set. Every number could belong to at least one set, and most belong to more than one set. 12 over 2, it is a real number. Again, every number is a real number until we get to imaginary numbers later on this year. Rational number is anything that can be written as a fraction. It is a fraction, so it is rational. It is also an integer. Doesn't look like an integer right now, but if you simplify it out, 12 over 2 is equal to 6, and 6 is an integer. It's also a whole number. 6 would be part of the whole numbers, and also part of the natural numbers. It is not irrational. It does not have a decimal that does not repeat or terminate, and it's not a square root. So the 5 sets of numbers: real, rational, integer, whole, and natural. Second number we'll look at is the fraction negative 2 over 9. Again, we'll take this number, go through all 6 sets of numbers, and see which it belongs. It is a real number. Negative 2 over 9 is also rational because it is a fraction, could be positive or negative. It is not an integer though. 2 does not divide evenly into 9, and therefore it's also not a whole number or natural number, and it is not irrational. 2 divided by 9, if you wrote it out in decimal form, the decimal would repeat or terminate. So this one is only real and rational. And last number for the section, the square root of 19. Again, square root of 19 is real. Every number is real until we get to imaginary numbers. Rational means you can write it as a fraction. You could change this into a fraction by putting it over 1, but the fraction has to have whole numbers or integers, cannot have square roots in the fraction. So it's not rational, therefore it's also not an integer, whole number, or natural. Square root of 19 cannot be simplified, which means it's an irrational number, a square root that cannot be simplified. There's also 4 properties in mathematics we can use with numbers. The commutative property, a plus b equals b plus a, means it doesn't matter which order you add the numbers, it'd be the same total. Associative, if you have 3 numbers, it doesn't matter which 3 numbers you add or how you add them together, it always adds to the same. Identity, if you add 0 to any number, it stays the same. Inverse, if you add the opposite of a number, it always adds to 0. For multiplication, the same 4 properties. Commutative, it doesn't matter which way you multiply 2 numbers. Associative, if you have 3 numbers, it doesn't matter how you multiply 3 numbers, it's always the same total. Identity, if you multiply by 1, it stays the same. And inverse, if you multiply by the reciprocal, it's always equal to 1. One extra property is distributive, where you can distribute a times b and a times c. Next section of notes is titled Name the Property. First question is 5a plus, in parentheses, negative 5a equals 0. Looking at the list of properties where you add the opposite and it's equal to 0, that is the inverse property. And also we're adding to make 0, so that would be inverse addition. Second question and last question for the section. In parentheses, 2 plus 14 plus 3 equals 3 plus, in parentheses, 2 plus 14. In this case, it looks like associative, but if you look closer at the problem, 2 plus 14 stays the same in each of the parentheses. It just changes from the first term to the second term. So this is actually commutative. And again, since we are adding, this is commutative addition. Title of the last section of notes is Simplify. Expressions. First problem, 7a plus 3b minus 4a minus 5b. Simplifying this expression, we can combine like terms. Like terms would be the same variables, so the a's we can put together, and also the b's we can put together. 7a minus 4a would be 3a, and 3b minus 5b would be negative 2b. So our final answer would be 3a minus 2b. Second question and last question for the section. 3, inside parentheses, 15x minus 9y plus 5, in parentheses, 4y minus x. Solving, we can use distributive property on the first parentheses, multiplying 3 by each of the inside terms. 3 times 15 would be 45x, and 3 times the negative 9y would be minus 27y. We can also use distributive property on the second set of And 5 times a minus x would be minus 5x. Again, we can simplify by combining like terms. The x's we can put together, and the y's we can put together. 45x minus 5x would be 40x. And negative 27y plus 20y would be negative 7y.